Good evening, Honors Algebra. This is Mr. Lawrence with your flipped lesson for Tuesday, December 6th. Today we are going to be graphing absolute value equations. All right. Yesterday we practiced on solving absolute value inequalities. Well, now we're actually going to graph absolute value equations. We're not going to be graphing them on a number line. We're going to graph them on an XY coordinate system. Let's say we had an equation that looks like this. Y equals the absolute value of x. That should look an awful lot like y equals x. Now, I'm going to graph both of these. I'm going to do a t-table for each. I'll do a t-table in black for the absolute value one, and I'll do a t-table in blue for the y equals x equation. Pay attention to what's going on here, guys. Check this out. All right, now I'm going to pick my points very deliberately. There's my x and my y. I'm just going to pick some x values, say like -3, -2, -1, 0. Oh no, I'm running out of room. Let me move this down. Oh, not that. Okay. Then 1, 2, and 3. All right, y equals x. Well, if x is -3, then y must be -3. If x is -2, then y must be -2. All I'm doing is plugging the x coordinate into this equation, getting the y coordinate out. Pretty simple stuff, right? Okay, if I plot those points, you'll see I get a line that looks an awful lot like this. I know I went a few extra points, but that's okay because they're still on the line. Let me do this one in blue. Oh no, I'm getting caught on my own microphone cord. Yikes. Okay, and that's awful big and thick, so let's make it smaller. And let's change the ends to arrowheads. Okay, there we go. Now I'm going to make a t-table for the black ones. And see if you can tell, make a prediction what's going to happen. I'm going to use the same exact x's and y's. So -3, -2, -1, 0, 1, 2, 3. All right, if x is -3, the absolute value of x is +3. When x is -2, the absolute value of x is +2. Remember, the absolute value of x is the distance from 0 on a number line. So if I'm at -2, how many spaces from 0 am I on a number line? Well, I'm 2 spaces away. Absolute value of -1 is 1. Absolute value of 0, 0. Absolute value of 1, 2, 3. What do you notice here about this t-table? You notice that they're going down, kind of converging, and then they go back up by the same amount. Well, let's plot these points. 1, 2, 2, 3, 3, but -1, 1, 2, 2, 3, 3. All right, and let me graph this one. It's going to look like this. Yeah, and it'll actually be a V. It'll actually be a V. The absolute value causes this blue part of the line here to shift up. It looks like a 90-degree angle, as a matter of fact. So it kind of takes the line and breaks it up. All right. Well, absolute value graphs are really some of the easiest graphs we're ever going to do. They're all going to have this V shape that the black graph has. Okay, they're all going to have that V shape. They're really similar to y equals mx plus b once you know the tricks. And I'm going to show them to you. Give me 1 second to get set up here. Let's take a look at this equation. Y equals the absolute value of x plus 4. What do you think is going to happen to this one? Well, it's going to be that standard V shape. I can't go and draw it yet, so I'll tell you what. I will make a t-table again. And on the homework, you're not going to have to make a t-table all the time because I'm doing the t-tables to help you see the tricks. All right, so let me see here. Let's use the points -2, -1, 0, 1, and 2. All right, I take the absolute value of -2 is 2. 2 plus 4 is 6. Absolute value of -1, 1. Plus 4 is 5. 0 will come up with an answer of 4. 1 will come up with an answer of 5, and 2 will come up with an answer of 6. So I'll plot these. Negative 2, 6, 1, 2, 3, 4, 5, 6. Negative 1, 5, 1, 2, 3, 4, 5. 0, 4, 1, 5, and 2, 6. So my line, or my V I should say, will look just like this. Yeah, it looks just like that other V that we did on the last graph, except it shifted up 4. Let me see if I can, oops, I don't want to do that. Let me see if I can get these connected. Hold on 1 second. Okay, I've got them connected. The original graph looked just like this. Its vertex was at 0, 0, and then it had points at 1, 1, 2, 2, 3, 3, and negative 1, negative 1, negative 1, 1, negative 2, 2, negative 3, 3, etc. Well, the adding 4 to the outside simply just shifted it up 4 units. That's all it did. So, in other words, it changed the y-intercept. Now, it won't always be the y-intercept, but what is important to know is that a number added or subtracted will shift the v up if it's positive, down if it's negative. If the equation had been y equals the absolute value of x minus 10, well, then the v would have shifted all the way down here. It would have stayed the same. Okay, that's pretty easy, isn't it? Okay, so let's see here. Let's get another one on here. Let's see what happens when we do something on the inside of the absolute value. Like y equals the absolute value of, say, x plus 4. And I do it on the inside of the absolute value. Okay, well, I'm going to make my t-table, right? X and y. And I'll tell you what, I'll use the same points. Negative 2, negative 1, 0, oops, 0, 1, and 2. And this is going to present a small problem, and you'll see why in a second, but that's okay. All right, if I put the absolute value of negative 2, excuse me, if I put negative 2 in for x, I get negative 2 plus 4, which is 2, absolute value is 2. I put negative 1 in for x, I get negative 1 plus 4, which is 3, absolute value 3 is 3. I put 0 in, I get 4, absolute value 4 is 4. And then when I put 1 in, I get 5. Notice how it's not breaking. It's before I was going down to a point and then going back up. So what I'm going to do to rectify that is I'm actually going to go with a couple more numbers. Let's see if I can get these to, yeah. I'm going to go with a couple more numbers this way. I'm going to go with, say, negative 3, negative 4, negative 5. And I'm going to watch what happens. All right. I put negative 3 in for x. I get negative 3 plus 4, 1. Absolute value 1 is 1. Well, it's going down. Negative 4 will get me 0. Negative 5 will get me negative 5 plus 4, negative 1. Absolute value of negative 1 is 1. Oh, there it is. There's where it starts to go back up the other way. Notice it's going 5, 4, 3, 2, 1, 0, and then back up to 1. If I do negative 6, put a negative 6 in there, negative 6 plus 4 would be positive 2. All right, so let me graph these points. I'll start with that negative 6. 1, 2, 3, 4, 5, 6, 1, 2. Okay, 1. Okay. And notice the V looks something like this. Okay. In fact, if we take this V from this problem here, I'm going to borrow UV here. Let me clone him so he'll stay there. All right. Clone him. That's the same exact V, right? It's the same V that was there. Now watch what's going to happen. It's the same exact V. This was the original V. 1, 2, 3, 4. This is the V from when we added 4 to the outside. And look at this. 1, 2, 3, 4. That is the V Same V, only this time it shifted left. It shifted left. Yeah. So we can conclude from that that when you add on the inside, you shift the V left. It's like the opposite. Inside the absolute value, it's the opposite. Inside the absolute value, you shift the opposite direction. If I had subtraction in there, I would have shifted the V right. Okay, so let's review really quick what we've learned here. We still have one more thing to do, but that's okay. All right, if I have an equation like this, y equals absolute value of x, that is going to look like a V. Can't find my lines. That's going to look like a V. Its vertex is going to be at the origin, right? Okay, let me group those together. Okay, so the black equation, I changed it from green to black, looks like that V right there. Its vertex is at the origin. On the right side, it's got a slope of 1 over 1. Left side, it has a slope of negative 1 over 1. Okay, 90-degree angle. Okay, now if I have an equation like this, y equals the absolute value of x, say minus 3, that's going to take that V, and that is going to shift it along the y-axis. It shifts it in the same direction as the sign. The sign is negative 3, a negative on a 3, so I'll shift down 1, 2, 3. So we've learned that this here shifts the V down 3 units. Okay? Remember, if it had been a plus, I would have shifted up. But now when I have an equation like this, y equals the absolute value of x minus 3. And I use different numbers on purpose this time, so you can see it's not isolated. That is going to shift the V along the x-axis, but it does it the opposite way. It's a minus 3, so I'll shift 1, 2, 3. And it shifts it there. So this negative shifts to the right, shifts the V to the right. Okay, and in this case, it's still going 3 units. All right, that's the 3 part there. So in a minute, we're going to put these together because you don't even need to make a t-table if you know where the vertex is going to go. Okay, remember on the black one, the vertex was at the origin, 0, 0. On the red one, the vertex was at 0, negative 3. On the blue one, the vertex was at 3, 0. I can tell that just by looking at the equations. All right, the bell is about to ring for the kids to come to class, so I'm going to pause this and I will be back with you soon to show you what happens next. All right. Okay, I'm back. So let's look at an example like this where we have y equals the absolute value of x minus 5 plus 2. Now, this is going to start off exactly like the other ones. Oops, I want to clone. Oh, I guess I did get it. Yep, there we go. Let me grab this guy down here. Our original equation was y equals the absolute value of x, right? Well, he looks like that. Okay. Well, this is kind of weird. Let me change the order. There we go. I'm going to change them to blue. All right. So there is the original equation. Now, remember, we learned in the previous examples that this will shift the vertex along the y-axis. It'll shift it up 2. That'll make the y-coordinate of my vertex positive 2. This one here shifts up 2. This one here will shift my vertex right. Why is it right? because for the ones inside the absolute value, you do the opposite sign. So I need to shift right 5 units. The new vertex will end up being 1, 2, 3, 4, 5, 1, 2. And there's the picture. There's the picture. Notice that there's no number here. If we were doing y equals mx plus b, and I wrote down y equals x, the slope would be the number in front of x. When there's no number there, we assume there's a 1. So in this case, it's like the slope is 1 over 1 for to the right of the vertex. To the left of the vertex is actually negative 1 over 1. Okay? So I'm going to give you a couple sample problems here. You don't actually have to graph them, but you have to identify the vertex. I'll do one for you. Hold on one second. Okay, in these 4 examples, they all have the same slope, that 1 over 1, or negative 1 over 1, depending on which side of the vertex you're on. But see if you can identify the vertex for each one. I'll do the vertex for number 1 here. I know that this shifts my v up 4 from 0, 0, so my y-coordinate is 4. I know that this shifts my vertex left 8 from 0, 0, so that would be negative 8, 4. So my new vertex will be at negative 8, 4, and then I can do the slope up 1, right 1, up 1, right 1, or up 1, left 1, up 1, left 1, and get the nice V shape. You go ahead and pause the video. The answers for 2, 3, and 4 will appear when you're done pausing. Okay, if you're unpaused, I assume you want to see the answers. And in this case, I'm going to get a y-coordinate of 6 and an x-coordinate of 10. On this third one, I'll get a y-coordinate of negative 5, an x-coordinate of positive 6. And then on the fourth one, I will get a negative 12 for the y-coordinate and a negative 2 for the x-coordinate. All right. Tomorrow in class, which will actually end up being, let me think here, today's Tuesday, so that'll be Thursday in class, you'll actually be getting some practice graphing these. All right, Mr. Lawrence signing off.